let's just talk our way through both of our question number 3s. We did number 1s, and we just posted the notes to number 2. But for number 3 in our assignment, going through the 6 things again, finding the discriminant and understanding what that means. Because we have our equation in standard format, the A, B, and C are 1, 9, and 1. The discriminant, quite often we just use the letter D for it, or uppercase D. B squared minus 4AC is 77. That tells me I have 2 real distinct roots. It also tells me that I'm not going to be able to factor this because I'm going to have the square root of 77 later on. And that's why I went straight to the quadratic formula to find my zeros. And again, I didn't put b squared minus 4ac underneath the radical sign. I just did the work to find the discriminant. So that's what I used. Nothing simplifies. So I have 2 zeros, negative 9 plus root 77, all divided by 2, and negative 9 minus root 77, all divided by 2. For C, to find your y-intercept, we always plug in the value of x equals 0 whenever you're on the y-axis. And from there, we just can do algebra. 0 squared, 9 times 0 plus 1. So again, the pattern that we want you to see is that the y-intercept is always the constant term when you're in standard form. So the letter C, the constant, will always be the point on the y-axis. The vertex, doing the algebra where you want to complete the square. Here's where I think some of us are falling short in regards to the number of steps we're showing. I really think that we want to talk about knowing that it's half a 9 and showing that information, and then half a 9 is 9 halves, leaving it like a fraction. This is really called completing the square, and inside here is some information, and really I don't know if we need to write the factors twice or not, but the idea is that we really want to know how you find the number 81 quarters. And it's either because you're seeing that it's 9 halves times 9 halves in the factors, or just the fact that whatever number you get, we just square it. But somehow there's some information or some connection to half of the b value and the factors, or squaring that number. And that's why it's 81 quarters. And like we talked about in the past, whenever you're doing these questions, we have to make sure that we balance things out. We can always only ever add 0 to our questions. We multiply by 1, divide by 1, or add 0. It doesn't change the function at all. So that's where the plus 1 and minus 81 quarters comes from. A little bit of math again. 4 minus 81. That should be 77 instead of 71. So let's fix that. I'm going to fix that a few places now, I guess. This will be minus 77 quarters. So my vertex is minus 77 quarters. When I talk about my range now then, I'm going to have to change this to 77 quarters. 77 quarters all the way through. So one little mistake there cost me dearly. So again, that was because it was negative. It's 4 minus 81 is negative 77. So once you have your vertex, you can sketch, and I didn't change the x value at all. So my axis symmetry is still x equals negative 9 halves. The other question 3, given some information, how do you find the equation when you have pieces of the puzzle given to you? This one's a little bit different again. Because we gave you zeros this time, negative 1 and 0, 3 and 0, if you know where the zeros are, you actually know the factors. To get a 0 of negative 1, your factor had to be x plus 1. And again, that kind of goes back to the idea that you have x plus 1 equals 0, x equals negative 1, so negative 1 is a 0. And the same thing we do with the 3. We could have talked about how x minus 3 equals 0, x equals 3. So looking at the information we have as well then, you got your zeros. We put the zeros in. I didn't put my x and y in to begin with. I just put my factors in because it was my 0 method, or my 0 steps. The x value though on a point was given to us as 5 and negative 6. So wherever you have x, I plug in the value of 5, and wherever I have y, I plug in the value of negative 6. I get an equation. Again, out of the 5 parameters, I know 4 of them. Or I guess out of the 4 parameters, I know 3 of them. I plug things in and I solve, and I find a stretch factor is negative 1/2. So all the way through now, whichever form of my equation I'm going to work with, I have to make sure that my negative 1/2 is always the a value. Expanding things from 0 to standard format, I'm just doing algebra, multiplying things out, and then I distribute through times by negative 1/2, and now I have an equation that is in standard format. So y equals 1/2 x squared plus x, negative 1/2 x squared plus x plus 3/2 is standard format. How do you complete the square? Again, mathematically, we have to make sure we're inside the brackets. I only have 1 x squared, so this is real important to understand that this is a 1x squared. When I factor the 1 out, or when I factor the negative 1/2 out, I have to make sure it comes out of not just one term, but it comes out of both terms. And we sometimes get stuck again with what it means to be factoring. It means you're dividing something. So if you take 1 and divide it by 1/2, you actually get 2. There's 2 halves in one whole. So 1 divided by negative 1/2 gives me negative 2. If you think about the reverse, you can multiply things back into the brackets. Negative 1/2 times 1, negative 1/2 times negative 2, and those numbers have to go back and give us the negative 1/2 x squared plus 1x. So they do. Completing the square again, take half of the negative 2 is negative 1. So my factors are going to be x minus 1 and x minus 1. To find what I'm going to add again, it's kind of like saying I have negative 1 times negative 1. Negative 1 times negative 1 is like saying taking the negative 1 and squaring it. So to make my perfect square, I have to add 1. So adding 1 in the brackets is not the same thing as adding 1 when I have a stretch factor of 1. What I really have happening here is I have negative 1/2 times by the positive 1. So I'm really subtracting 1/2 in my expression. And to keep the 0 there, I actually have to balance out, subtract 1/2 with add 1/2. And again, just some fraction work, 3/2 and 1/2 go together, give me 4/2. So I really have plus 2 outside my brackets. And the work I showed earlier on, it's x minus 1 times x minus 1, so it's x minus 1 squared. So here's our vertex form then. Negative 1/2 is key, right? The a value doesn't change no matter which format you're in. It was negative 1/2 in part A, it's negative 1/2 in part B, and it's negative 1/2 in part C. How does that affect your range? It just tells you that your graph is going to open down. So instead of having a minimum value this time, we have a maximum value. The graph does not stop, so it goes down to negative infinity. If you read it just from the y value, y is less than and equal to 2. So hopefully that was enough information to help guide you through those last two examples.